So now that we know primitive data type and basic control statements, we're going to put them together to write a program that will allow us to choose cheap audiobooks. Here's the problem statement. I have a subscription to Laudable.com, an online retailer that sells audiobooks. Each month I get 1 credit for a fixed fee of $14.95. Each book has a title, a length in hours and minutes, and a number of credits. We're going to write a program that reads the data for the books and chooses the ones that's the best value. What I mean by the best value is the one where you get the most number of minutes of time for the given credits. That's probably not a very good way to choose audiobooks, but it's what we're going to do this morning anyways. And we'll end the input with a semicolon of end. Now that we're doing test-driven development, we want to write the test data for the program first. So here's some possible input. Let's say A Tale of Two Cities took 150 hours and 5 minutes and cost 1 credit. Now, I don't know if it really took that long, but it probably seemed like it took that long. A Tale of Three Cities could take 100 hours and 55 minutes and cost 1 credit. A Tale of Four Cities could take 50 hours and 20 minutes and cost 2 credits. And A Tale of Five Cities could take 150 hours and 5 minutes and cost 3 credits. When we look at these, we can see that A Tale of Two Cities is the one that's going to be the best value. And so that's the one we'll have as the output. Notice that there is some unnecessary information in this problem statement. This is actually very typical of what you get when you talk to people who want you to design software for things. They tell you all kinds of stuff that you don't need to know, and then you have to pull out the things that are really relevant. In this case, the fact that a monthly subscription costs $14.95 is irrelevant. It's all about credits. We might consider some boundary cases here, like what happens if there aren't any audiobooks. I guess that case doesn't particularly make sense, because if there aren't any, you're not going to buy any. If there's one, it will be the best deal automatically. So those are some good boundary cases this time. We might also consider what happens with ties. Ties are one of those things that tend to be a problem in computer science. One strategy that you can use is sort of first come, first serve. That is, if you find another value later that ties your first one, the first one is the one that remains. It really doesn't matter which way you settle ties, but it's very important that you let people know how they're settled so they know what to expect. Here's a tough question. How much test data is enough? I've only put one piece of test data here, and that probably isn't enough. But you could go on writing test data all day and all night, and so you have to balance that. For this program, given that it's a relatively simple program, probably this is sufficient test data. We can always test more later. The next thing we're going to do is create our class, so let's go to Eclipse. I'm opening Eclipse from the Launchpad, entering our workspace. So let's create a new project for Laudable.com. Remember, project names are allowed to have periods in them, so this will work fine. When we get to creating our class, however, we're only going to be able to use Laudable. Once again, I'm having a main program put in the class. Now in this case, I forgot to select the source directory when I started in, so I'm going to have to browse for it now. So I'm going to find the Laudable.com project and select the source directory as the place where I want my class file. One thing you'll notice is that Eclipse is giving us a little warning here. It's saying the use of the default package is discouraged. And actually, Eclipse is right on this one, but it's okay for beginning programmers. We'll learn how to work around that later. So here's our class, and as always, we're going to need to beautify it a little bit. And it's been pretty handy having our problem statement moved in. So let's go and grab that from our PowerPoint. And put that as a comment at the top. Now that got a little bit ugly, so we're going to beautify it a little bit too. Notice that I'm keeping it well within the bounds of the code that we can see. That's always a good strategy. The next thing to notice is the input and the calculation are intertwined here, as they have been in our last several programs. Don't worry, we're going to stop having that soon, and so you'll see something different. But for right now, they're together. And so this means that both the input and calculation are going to have to be part of our method signature. The parameter, once again, is going to be the scanner object that we bring in from the main program. Now we might want to think about the return type. What exactly is it that we want to get? Well, if you look back at our output data that we did in our test-driven development, you'll see that our output was a tale of two cities. That's a string. And so that's definitely what we want to have. Let's look at our method name inside the program. Remember that the methods go outside of the main method but inside the class. Now I'm going to make a mistake here on purpose because there's a very simple thing to forget, and that's to put public and static in front of methods. And it gives a really crazy message, so I want you to see that message once. So our return type was going to be string. We're going to read and find cheapest book, and we're going to have an input scanner. Now, as always, we need to remember to import java.util.scanner. So that the program doesn't complain. And here let's just return, help me. So we're going to call this from our main program now. We'll need to create our scanner object here. New scanner system in, same as usual. And we'll call our read and find cheapest book stub from keyboard. And you'll notice right now that Eclipse still has a red X. You'll see this red X a lot. This is a very common mistake to make. So let's look at the error message. Cannot make a static reference to the non-static method read and find cheapest book of scanner from the type laudable. That's really not a very helpful message, but it does have a couple of keywords in it that will help you remember how to fix it. When it was talking about static and non-static, what it was trying to say was that this method that we're calling here, the read and find cheapest book, is not a static method, and we called it from a static method. That combination isn't allowed. The way you fix that problem is by putting public static in front of the method. Later on we'll have different strategies, but for right now all of our methods will be public and static. The next thing we need to do is to read our input in. We'll have a title, and that should be on one line, and then the numbers of hours and minutes and credits. Now there is a problem if you put the hours and minutes and credits on the same line as the title. That doesn't work, because when we read in, our choices are to read in things between spaces, in which case we would only get the first word of the title, or to read in whole lines, in which case we'd get the title and the hours, minutes, and credits. So we have to have those things on two separate lines. The other thing we need to think about is, do we have our next versus next line problem again? We talked about this problem in a previous video, and it's a constant thorn in our side when it comes to reading input. So we'll think about that when we're writing our code. So let's go and write our code. So inside the method, we're going to create a string for the title, an int for the hours, an int for the minutes, and an int for the credits, because all of those things are integral. We're going to need a loop. Let me move our console out of the way so we have a little bit more space to work. Now, in this case, Even though we're still going to have a while loop, this is a sentinel-controlled loop instead of a counter-controlled loop. And so we're going to have to use priming reads to make this work. So that means we're going to prompt the user before the loop and get data before we enter the loop. Then we'll start our while loop, and inside the while loop at the bottom is when we'll read the data for the next execution. That's the only way that you can get sentinels to work properly in code. So we'll do system out print line, enter the title of your book on one line, and system out print line, and the hours, minutes, and credits on another line. Notice I'm giving the user some very specific instructions because it makes a big difference that they enter things correctly. So title will equal input dot next line, because we know it's on a line by itself. Hours will equal input dot next int, because it's an integer. Minutes will equal input dot next int, and credits will equal input dot next int. So there we have all of our data. Now it's time to think about whether we have the next versus next line problem. After we finish reading credits, there is a new line character that's sitting on the screen. That's what gets entered when you hit enter on your keyboard. So if we go and read the title now using next line, it will get that empty character, and it won't get the title correctly, and then our program will break immediately. So we have the next line problem, and we need to use next line again to get rid of it. So we do input.nextLine. Now things like that are really hard to figure out when you're reading the code, so you definitely want to put a comment there to explain what's going on. I'm going to put this one on the side. Read in the carriage return at the end of the line. You don't always think of doing things like this when you're reading input initially, but you'll remember to do it once you've programmed a bit and had your programs break every time you forget. So this is before the while loop. Now we need our while loop. Title equals end. And we want a not in front of that, of course, because we want to stop when the title equals end. We want to continue when the title is not equal to end. Remember that we use equals because we're comparing strings here, and so that makes a difference. The other thing that we might notice is that we didn't actually tell the user about that end thing. That's going to cause problems because they won't know what to do. System out print line, enter end when the program is finished. So now we've given the user correct instructions. Oh, I see Eclipse is unhappy once again about credit. That's because I called it credits above instead of credit. We can fix it either way, but that will get rid of the little red X. Okay, so here's our while statement. The other comment we haven't put in here is that we're doing priming reads. You definitely want to tell somebody who's reading the code about that. Remember, all this stuff is going to go at the end of the loop too, so we will copy it. Notice I even copied the comment in and put it in there. We're trying to find the cheapest book. We've read in the number of hours, the number of minutes, and the credits, and so what we need to calculate is the cost per minute in terms of credits. So let's make a comment about that. So we need a double for the cost per minutes. The value of that will equal the number of hours times 60 plus the number of minutes divided by the credits. We want to think about our precedence a little bit because we may not have the precedence correct. So remember, multiplicative operators like times and divide get done before additive operators. So we definitely want to put some parentheses around here. I actually like to put in a lot of parentheses in my programs anyways, because it makes it clearer what your intention was. This is what we want. The total number of minutes to be calculated first, and then the credits be divided out at the end. The next thing we need to do is to find the minimum. Now we've done the minimum thing before, so we know we need a variable to keep track of the minimum. So we'll call it minimum cost per minute. And we have to think about what this value should be set to. Now this is a double value, so we can't use integer max value like we did before. That isn't going to work, and it turns out the double class doesn't have a maximum value. So we might want to think about how we could initialize this. Well, one easy way to do it is to initialize it to the cost per minute of the first value. That way we know we'll have a legal value. We can grab that right from here. We can't use cost per minute up there because it's declared inside the loop, and so it's out of scope at this point. But the other values still work. Now if you think about it, in addition to knowing the minimum cost, we also want to know which book had the minimum cost. So we're going to need a string to store that. So we'll call it cheapest book so far. And that's going to be the title of the first one. Inside the loop, if the cost per minute is greater than, less than, cheapest book so far, what that means is we found a new book that's cheaper. So cheapest book so far will get the value of cost per minute. And, I'm using the wrong variable. Cheapest book so far is our string, so that should get the value of title, not cost per minute. Notice that Eclipse was telling me that I was making a mistake there, and if I had paid attention to it a little bit sooner, I might not have typed so much stuff wrong. Cost per minute has to be less than minimum cost per minute. I expect Eclipse is about to be happier soon. Minimum cost per minute equals cost per minute. So we've got an interesting structure here. Between the priming reads and the if statement in the middle of the while loop, we've got a pretty substantial while loop. So let's put in some more comments to help it make more sense. So find whether the current element is the minimum. So notice we've got 2 or 3 lines of code and a comment before each. That's a really nice balance in code. Then we've got our priming reads. And now instead of returning help me, we can return cheapest book so far. So it looks like we may have our method done, or at least we will when I put the C back in cheapest. Now is a good time to test. So here we go. So we have a tale of 2 cities, and it's going to run for 500 hours and 5 minutes and cost 1 credit. Then we have a tale of 3 cities, and it's going to run for 250 minutes or hours and 10 minutes and cost 1 credit. And then we have a tale of 4 cities, and it's going to run for 100 hours and 55 minutes and cost 5 credits. And then we're at the end. Uh-oh, something went wrong. We don't see any output. Now, what's happened here is actually an input problem, and we're going to have to go to the code to see it. One of the things that you can notice here is that this little red box is still lighted up. That means our program is still running. The real problem here is we didn't give the user very good instructions, because when they enter end, as you'll see when we look at the code, the title gets read, and then the computer is waiting to read the hours and minutes and credits. It can't tell that end has been read if we don't tell it. And so we need to put an if statement in here to fix it. So if title equals end, a curly brace to start, and a curly brace to end, we're going to move those over. Now we might want to think about it very carefully. Do we want to do this when title equals end or when title is not equal to end? Well, we go on and read the input when title is not equal to end. So that means we need a little exclamation point here to say not. So now if we get end, we don't try to read the other things. Now there are other ways that you could have tried to fix this program. For example, you could have prompted the user to enter end and then to enter fake data. But that isn't respectful to users, and it makes your programs look unprofessional. So we don't do things that way. Let's run the program again and see if it works. Here we go. A tale of two cities. 500 hours, 5 minutes, 1 credit. A tale of 3 cities. 250 hours, 10 minutes, 1 credit. A tale of 4 cities, 100 hours, 55 minutes, 2 credits. And a tale of 5 cities, 50 hours, 25 minutes, and 3 credits. Here comes the moment of truth. We're entering end, and our program stopped. Now, why did our program not give any output? Well, that's easy. We didn't write any output for it to give. So we need to go back to our main program and fix that. Some people, when they develop programs, write the output first, and then write the calculation, and then write the input. That strategy is called backward chaining, and it can work really well. So notice here, even though we returned the title, we didn't store it in a variable, and we didn't print it out. Let's store it in a variable. Best title equals, and then print something out to the user. System out, print line. The cheapest book is best title. Notice that I was careful to add in a space after the cheapest book is, so all the words didn't get smashed together. I notice though that I've gotten a couple of extra little lines, so we want to get rid of those. We're ready to run again. Here we go. A tale of 2 cities. A tale of 3 cities. A tale of 4 cities. And a tale of 5 cities. And the cheapest book is A Tale of 5 Cities. Uh-oh, what happened? We need to go back and look at the logic in our program again. So we know this has to do with the calculation. So we have the hours times 60 plus minutes. Now let's think carefully about what's going on here. When we have the hours times 60 plus minutes, all of these things were integers, as were the credits. That means that we did integer division. Remember, that's one of those troublesome operations. So we might want to think about how we could fix that. Well, the easiest way is to make one of the values integers. One way that people sometimes try to fix it is by casting to double early on, and that can work, but where I like to cast is right here. I like to cast the denominator, so that tells it to use the number of credits. So we fixed one problem. Let's see if that solves the issue. Remember, there's often more than one problem in code. So here's our test data being entered again. Uh-oh, it's still a tale of five cities. So even though we fixed one problem, we didn't fix all the problems. This is very typical of program development. So we think that this may be correct. So let's look at this comparison. If the cost per minute is less than the minimum cost per minute, then the minimum cost per minute becomes cost per minute. That seems correct, so that probably isn't the problem. Let's look and see how we initialized cost per minute and see if we did that correctly. Well, the minimum cost per minute was originally set to hours times 60 plus minutes divided by credits. Uh-oh, we used that formula over and we didn't fix it. So let's fix this one too. Now we don't know if this is the ultimate problem, but it's one more problem with the code that we're fixing. Here we go. Same old data. And you may have figured out what's wrong with the problem what's wrong with the program already. In which case, good for you. That's a skill you learn. We're still at a tale of five cities. Well, let's give it a little bit more thought here about what we've done. Did we really calculate the cost per minute? Or did we calculate the minutes per credit? We have our equation upside down. These are the mistakes you make all the time when you're programming, and you definitely need to learn to spot them. There are a couple of different ways we could figure it. One is we could change our calculation to look for the maximum number of minutes per credit. That's probably a really good solution here. Then we don't have to turn our mathematical equation that we spent so much time working on upside down. Now I hasten to add that the two errors we found in the program before were real mistakes, and we were going to have to fix those sooner or later. So the fact that we fixed them before this one instead of after, that doesn't matter. So let's go and change some variable names and get our program doing the right thing. What we're going to want now is the maximum minutes per credit. Now see, that makes a lot more sense one way or another because you've got minutes in the numerator and credits in the denominator. Although notice our credits have scrolled off screen, which makes them hard to read, so we're going to move them over. Now our cheapest book so far, that part is okay. Instead of cost per minute, we'll change this to minutes per credit. And we'll have to move this and change it all the way down. So this is now maximum minutes per credit, and this is now minutes per credit. And we'll have to change these too. and everything else looks fine. When you make those kind of changes, make sure you check over to this side to make sure there are no little red boxes, and over on this side for red X's, because Eclipse will tell you if you found everything or not. Okay, so maybe our program is going to work this time. $500 hours, 5 minutes, 1 credit. Cross your fingers. The cheapest book is A Tale of Five Cities still. Okay, so we really have a problem here. So we need to look and see what's going on. Well, we think we fixed that okay, but look at what we did in this part of the statement right here. We changed our words to be maximum instead of minimum, but we forgot to change our mathematical symbol, and that's why it didn't get fixed. When we're finding a maximum, we want to change it when it's greater, not when it's smaller. The other thing to think about is how we initialize that to start with. Now it happens that we initialized it to the first value, and so that should still work okay. If we had initialized it to a small number, we would have to reconsider that when we change it to minimum to maximum. One more time. A Tale of Two Cities. Alleluia. Notice also that having our test data in advance really helped us out here, because then when we made a mistake in the program, we were able to find it. Here's something to think about with a program. Is it possible to test a program too much? Well, yes, but no one ever really does. In fact, testing programs is not really the greatest way to check and see that they're working or not. There is a better way to make sure that your programs are correct. It's actually possible to prove that a program is correct. Now, this is a very advanced technique. It's not something that beginning programmers usually learn, but it's a really great idea, and it is important because so much of what we do with software now depends on the software working correctly. Is it really possible to prove that programs are correct? Well, yes, not only is it possible, you can even automate the process. If you're interested in things like this, you're going to want to learn a language where it's a little easier to do this. One of the easiest languages to learn that does this is a language called Lisp. I actually wrote my doctoral dissertation research code in Lisp. It's a wonderful language to use. It's called ACL2 if you look for it online, and it's a really good language for proving that programs are correct. If you're interested in this part of computer science, you may want to take CS 2603, Applied Logic for Hardware and Software. That class has this class as a prerequisite, so you could do it next semester.